Good afternoon, grade 9. Today, I am going to discuss about reduction oxidation reaction or redox reaction. This is teacher Mildred and this is chemistry grade 9. Let us start by asking the question, what is a redox reaction? There are two definitions that we can give for a redox reaction. The first one is the definition in terms of gaining and losing oxygen. Oxidation reaction is the gain of oxygen, while reduction reaction is the loss of oxygen. Let us have an example of a redox reaction. Suppose you are given the equation copper 2 oxide plus hydrogen gas to give you copper plus water. Take note that hydrogen gas changes into water, meaning it undergoes oxidation reaction since it gained oxygen. On the other hand, copper 2 oxide changes into copper, meaning it undergoes reduction reaction since it's losing oxygen. The substance which undergoes oxidation reaction is your reducing agent or the reductant, and the substance which undergoes reduction reaction is your oxidizing agent or your oxidant. There is another definition for a redox reaction in terms of electron transfer. Oxidation reaction is the loss of electron. Take note, LEO, loss of electron, oxidation. And reduction reaction is the gain of electrons, or JER, meaning gain of electrons, reduction. Again, let's see the difference between oxidation and reduction reaction. If it's oxidation electron, the atom loses electron. Or oxidation is the loss of electrons or an increase in oxidation state by an atom, molecule, or ion. A reduction reaction involves the gaining of electron by an atom. Or reduction is the gain of electrons or a decrease in oxidation state by an atom, molecule, or ion. Let's say, for instance, compound A loses electrons. It means that compound A undergoes oxidation reaction. Therefore, it was oxidized, and it is our reducing agent. If compound B gains electrons, meaning it undergoes reduction, or it was reduced. Therefore, compound B is our oxidizing agent. The next question would be, how are we going to know if an atom gained or lost electrons? You need to look at the changes in their charge or oxidation number. If the charge changes from positive to neutral or zero, it means you gain an electron, while if it changes from neutral or zero to positive, it means that you lose an electron. Second, if the charge changes from positive to negative, it means that you are gaining an electron. On the other hand, if the charge changes from negative to positive, it means that you lost an electron. Third, if the charge changes from zero or neutral to negative, it means that you gain an electron. And if the charge changes from negative to zero or neutral, it means that you lose an electron. Therefore, you gain an electron if the charges changes from positive to zero, positive to negative, and 0 to negative. And you lose an electron if the charges changes from 0 to positive, negative to positive, and negative to 0. Let us have a summary for that part. Remember, oxidation reaction is the gain of oxygen, loss of hydrogen, loss of electrons, or an increase in oxidation number, while reduction is the loss of oxygen, gain of hydrogen, gain of electrons, or a decrease in oxidation number. For example, if substance A lose an electron to become A positive from A neutral, therefore substance A undergoes oxidation reaction. If substance B changes its charge from 0 to negative, it means that it gained electron and undergoes reduction reaction. Let us now start writing the half equation for oxidation and reduction reaction. I have here some steps that you could follow before you write the half equation. First, check if the equation is balanced, and if not, balance the equation. Second, assign the charges or the oxidation number of each element or compound. Third, if it is only an element and it's not a compound, the charge of the element would be neutral or 0. Cancel the substances which did not change its oxidation number or charge after the reaction. At this point, you are now ready to write the half equation. Let's have our first equation. For example, you are given the equation copper 2 oxide plus hydrogen gas to give you copper plus water. First step, you need to check if the equation is balanced. In this case, the given equation is already balanced, so we can proceed to step number 2. Step number 2 is you need to assign the charges. Since it is copper 2 oxide and we all know that the oxidation number of oxygen is -2, therefore it means that the charge of copper in this case is +2. Hydrogen gas is an element, although it's a diatomic molecule since it is a gas. Therefore, the charge of hydrogen gas would be neutral or 0. Copper on the product side is an element, so therefore the charge of copper would also be 0. And take note of the charges of hydrogen and oxygen in water. We know that the charge of oxygen is -2 and the charge of hydrogen is +1. In the given equation, you have 2 atoms of hydrogen. So therefore, it would be 2H with the charge of +1. After assigning the charges of the substances, let us now see the changes in the charges. For hydrogen gas, the charge changes from 0 to +1, which means that you lose an electron since the charge changes from 0 to positive. Hydrogen gas therefore undergoes oxidation reaction. For copper, it changes from +2 to neutral, meaning the charge changes from positive to 0. It means you gain an electron. Therefore, it undergoes reduction reaction. For the case of oxygen gas, take note that the charge did not change from -2 in the reactant side and -2 on the product side. So the charges would be -2 to -2. Since there's no change in the charge, oxygen gas would be cancelled. At this point, we are now ready to write the half equation for the reduction and oxidation reaction. For reduction, since copper changes from +2 to 0, it means that you gain electrons. For you to know the number of electrons that you gain, multiply the charge to the number of atoms present of that element. So for example, I have one atom of copper times 2 since the charge is 2, and then since I gain electron, the symbol would be positive. So therefore, it would be copper +2 plus 2 times 1 atom of copper is equal to 2 electrons, giving you copper neutral. And copper, since it undergoes reduction reaction, is my oxidizing agent or my oxidant. On the other hand, the half equation for the oxidation reaction would be hydrogen gas, neutral, and then minus 2 electrons to give you 2 hydrogen positive. So since you are losing electron, therefore the symbol would be minus. And where did I get the 2 electrons? Going to the other side, I have 2 atoms of hydrogen and the charge is positive 1. So 2 times 1 means you have 2 electrons. And since hydrogen undergoes oxidation reaction, therefore it is my reducing agent or my reductant. Take note, the number of electrons that you are gaining should always be equal to the number of electrons that you are losing, or vice versa. That's why we always need to check if the equation is balanced. To summarize what we have discussed about the meaning of oxidation and reduction reaction in terms of losing and gaining oxygen and losing and gaining electrons, I have here two sample equations. For the first equation, take note that magnesium changes from magnesium neutral to magnesium +2. Magnesium therefore loses electrons and undergoes oxidation reaction. Magnesium also is my reductant or reducing agent. On the other hand, copper changes from copper +2 to copper neutral, meaning it gains electrons. So copper therefore undergoes reduction reaction and it is my oxidant or my oxidizing agent. For the second equation, take note that iron 3 oxide changes to iron, meaning it loses oxygen. So iron 3 oxide undergoes reduction and is my oxidizing agent or oxidant. Carbon monoxide changes to carbon dioxide, meaning you gain oxygen. And so therefore, carbon monoxide undergoes oxidation reaction and it is my reductant or reducing agent. Let us now do the second example for the oxidation and reduction reaction. The given equation is Na plus CuSO4 to give you Na2SO4 plus Cu. First step is to check if the equation is balanced. Obviously, the given equation is not balanced since I have only one atom of Na on the reactant side, but I have two sodium atoms on the product side. So to balance the equation, I need to add 2 in front of Na on the reactant side, so my equation would become 2Na plus CuSO4 to give you Na2SO4 plus Cu. Next step is to assign the charges of the given substances. Since Na on the reactant side only exists as an element or atom, the charge would be neutral or 0. Therefore, you would have 2Na neutral plus. We all know that SO4 or sulfate has a charge of -2. Therefore, the given copper here would have a charge of +2. Going to the product side, I have two atoms of Na and the charge of Na is +1. So it would become 2Na positive. And again, SO4 has a charge of -2 plus Cu, which only exists as an element, so therefore the charge of Cu would be 0 or neutral. Let us now take a look at the changes in the charges. Na changes its charge from Na neutral to Na positive, to Na0 to 2Na positive. Therefore, it loses electron. On the other hand, copper changes its charge from 2 positive to copper neutral, meaning copper gained electrons. Writing the half equation for oxidation would be 2Na minus 2 electrons to give you 2Na positive. So where did I get the 2 electrons? I have 2 atoms of Na times multiply it to the charge which is +1 or 1. So 2 times 1 is 2. And since it's oxidation or you are losing an electron, the symbol would be minus. Therefore, it would be 2Na minus 2 electrons to give you 2Na positive. And Na or sodium is my reducing agent or my reductant. The half equation for reduction would be Cu +2 plus 2 electrons to give you Cu neutral. Again, where did I get the 2 electrons? I have one atom of copper and it has a charge of +2. So 1 times 2 is 2. And since you are gaining electrons in reduction, so the symbol would be plus. So therefore, the half equation would be Cu +2 plus 2 electrons to give you Cu neutral. And copper is my oxidizing agent or my oxidant. Again, take note that the number of electrons that you are losing should always be equal to the number of electrons that you are gaining and vice versa. Let us now proceed to example number 3. The given equation is Fe plus O2 to give you Fe2O3. First step, check if the equation is balanced. And obviously, the equation is not balanced. To balance the equation, I need to make the number of iron and oxygen equal. Balancing the equation would be 4Fe plus 3O2 to give you 2Fe2O3. So I have 4 iron or Fe in both sides and I have 6 oxygen atoms in both sides. Next is to assign their charges. Since Fe on the reactant side exists as an element, so therefore the charge of Fe would be 0. So it would be 4Fe0. Now, since I have 3O2, it means that the total number of oxygen atoms is 6. So I have 6O and the charge would be 0 since it's only an element and it is not in a compound. Going to the product side, I have a total number of 4Fe. And the charge of Fe here, looking at the compound, is +3. So I have 4Fe with a charge of +3. And the charge of the given oxygen here is -2. And the total number of oxygen, I have 2 times O3 is 6. So I have 6O negative 2. Let us now see the changes in their charges. Fe changes from 0 to positive 3. So 4Fe0 becomes 4Fe positive 3. So therefore, Fe loses electrons. For oxygen, it changes from 0 to negative 2. So 6O0 changes to 6O negative 2. The change in the charge is 0 to negative 2. Therefore, oxygen gained electrons. Writing the half equation for oxidation and reduction, your half equation would be, for oxidation, 4Fe0, and since again you are losing an electron, so the symbol would be minus 12 electrons to give you 4Fe positive 3. And where did I get the 12 electrons? I have 4 atoms of Fe with a charge of positive 3. So 4 times 3 is 12. That's why I loses 12 electrons. And for reduction, it would be 6O0 plus 12 electrons to become 6O negative 2. Since again it's reduction and you are gaining electrons, so the symbol would be plus. And where did I get the 12 electrons? I have 6 oxygen times the charge is 2. So 6 times 2 is 12. Therefore, Fe is my reducing agent or reductant because it undergoes oxidation reaction, and oxygen is my oxidant or oxidizing agent since it undergoes reduction. Again, looking at the half equation, you would notice that the number of electrons that you lost, which is 12, is equal to the number of electrons that you gained, which is also 12. It is now your turn to write the half equation for oxidation and reduction reaction. I have here practice exercise for you. Write the half equation for the following. First equation, Mg plus AgNO3 to give you MgNO3 plus Ag. And the second equation would be Al plus O2 to give you Al2O3. Remember, follow the steps before you write the half equation. And take note, always check if your equation is balanced. And that's the end of my discussion about reduction-oxidation reaction. Answer the practice exercise in your notebook and submit to me.